Good evening, guys. So today's topic is about sensors and motors and all what are the elements you use in embedded system. So what do you mean by a sensor? Does anybody know about this? What do you mean by a sensor? Or where do we use the sensors? So where do we use these sensors? What do you mean by sensors? Where do we use them? For what purpose do we use sensors? I speak up. What do you mean by sensor? What is the purpose of using a sensor? So sensors. The sensors are defined as machine, module, or a device that detects changes in the environment. Which means it is used to sense or detect the changes in the environment. The sensors transfer those changes to the electronic device in the form of a signal. So sensors will receive the signals and sense the signals. So here if you connect an instrument or electronic device to the sensor, sense the like it transfers the information in the form of a signal. Okay, a sensor and an electronic device always work together. The output signal is easily readable by humans. So if a sensor sends the signals to the electronic device, then it shows some reaction. So it has that electronic machine shows some output which is readable by a human. Okay. So nowadays sensors are used in daily life. For example, controlling the brightness of the lamp by touching its base. The use of sensors is expanding the new technologies. Okay, this is the main usage of sensors. How, we use, how it is useful for us. Where do we use sensors? Now, guys, some of you give me some examples of a sensor usable device. The devices which are having sensors. Just give me some examples of the sensor, the devices which are having sensor. Guys, turn on your mic and respond. Until your response, Then we will know next slide will be presenting for you guys.
Now you're waiting.
Guys, please to respond. Give an example of electronic devices which are having sensors. Why you guys are not responding? Examples will be explained for you guys. You need to know what are the examples of electronic devices which will be using sensors. So what is a sensor made of? So a sensor is a device which is made up of single crystal silicon. So it is considered so it is considered as widely used semiconductor material. It has superior mechanical stability, machinability, etc. It can also combine electronics and sensing elements on the same substrate where the sensors are used. The sensors can be used to measure the physical quantities such as pressure, temperature, sound, humidity, and light, etc. An example of sensors is fire alarm. A detector present on the fire alarm detects the smoke or heat. The signal generates from the detector is sent to the alarm system, which produces an alert in the form of alarm. The types of detectors are smoke detectors, heat detectors, carbon monoxide detectors, multi-sensor detectors, etc. How are the sensors used in or the data signals run from the sensor to the output pins in the Arduino. The data is further recorded by the Arduino. So what are the types of sensors present are listed here. Light sensor, ultrasonic sensor, temperature sensor, mach sensor, object detection sensor, tracking sensor, metal touch sensor, water level sensor, vibration sensor, air pressure sensor, pulse sensor, capacitance sensor, microphone sensor, motion sensor, humidity sensor, vibration sensor, sound sensor, pressure sensor, and magnetic field sensor. These were some of the major sensors which we use usually in the embedded systems. So what do you mean by light sensor? So light sensor is used to control the light. It is used with LDR, which stands for light dependent resistor in order. Ultrasonic sensor. Ultrasonic sensor is used to determine the distance of the object using sonar. Temperature sensor. The temperature sensor is used to detect the temperature around. Knock sensor. Knock sensor is used to pick the vibrations of the knocking. It is a common category of vibration sensor. Object detection sensor. It is used to detect the object by emitting infrared radiations which are reflected or bouncing back by the object. Tracking sensor. It allows the robots to follow a particular path specified by sensing the making or lines on the surface. Metal touch sensor. It is suitable for detecting the human touch. So once again, device is So next, water level sensor. So it is used to measure the water or the depth of the water level. It is also used to detect leaks in containers. Vibration sensor. The vibration sensor is used to measure the vibrations. Capacitive soil moisture sensor. It is used to measure the moisture level of the soil. Microphone sensor. The microphone sensor in Arduino is used to detect the sound. The analog and digital are the two outputs of this mobile. The digital output sends the high signal where the intensity of sound reaches a certain threshold. We can adjust the sensitivity of the module with the help of a potential humidity sensor. The humidity sensor is used to monitor weather conditions. Motion sensor. The motion sensor detects the movement and occupancy from the human body with the help of infrared radiations. Sound sensor. The sound sensor is suitable to detect the sound of the environment. Pressure sensor. The pressure sensor is used to measure the pressure. The sensors in Arduino measures the pressure and displays it on a small LCD screen. Magnetic field sensor. The magnetic field sensor measures the magnetic field strength and produces a varying voltage as the output in Arduino. So this is how air pressure sensor and pulse sensor looks like. What is meant by an air pressure sensor? It is commonly related to meteorology, biomedical fields. It looks like below image. So pulse sensor. It is used to measure the pulse rate. Okay, this is how a rate with a sensor and a pulse sensor looks like. So next we learn about RFIDs. What do you mean by RFID? What is the full form of an RFID? Where do we use these RFIDs in our day-to-day life? What do you mean by RFID? What is the full form of an RFID at least? What do you mean by RFID? What is the full form of an RFID? So RFID tags the technology once related to tracking cattle and tracking consumer products worldwide. Many manufacturers use the tags to track the location of each product they make from the time it's made until it's pulled off off the shelf and launched in the shopping cart. One side, the realm of retail merchandise. RFID tags are tracking vehicles, alien passengers, Alzheimer patients, and pets. Soon they may even track your preference for chunky or creamy peanut butter. Some critics say RFID technology is becoming too much a part of our lives. That is, if we are even aware of all the parts of our life that it affects. In this article, you will learn about the types of RFID tags and how these can be tracked through the entire supply chain. So RFID tags in an improvement over barcodes because the tags have read and write capabilities. So data stored in RFID tags can be changed, updated, and locked. Some stores have begun using RFID tags have found that the technology offers a better way to track merchandise for stocking and marketing purpose. Through RFID tags, stores can be how quickly the products leaves the shelf and which shoppers are buying them. RFID tags won't entirely replace barcode in the near future. Far too many retail outlets currently the UPC scanners in billions of the transactions every year. But in time goes, we'll definitely see more products tagged with RFIDs and an increased focus on seamless wireless transactions like that rosy instant checkout picture painted in the introduction. In fact, the world is already moving toward using RFID technology in payments through special credit cards and smartphones. We'll get into that later. In addition to retail merchandise, RFID tags have also been added to transportation devices like highway toll pass cards and subway passes. Because of their availability to store data so efficiently, RFID tags can tabulate the cost of tolls and fares and deduct the cost electronically from the amount of money that the user places on the card, rather than waiting to pay a toll at the toll booth or selling out coins at a token counter. Passengers use RFID chip embedded passes like debit cards. But would you interest your medical history to an RFID tag? How would your own address or your baby safety? Let's look in. Let's look at two types of RFID tags, how they store the transmit the data before we move past grocery store purchases to human life. So RFID tags past and present. RFID technology have been around since 1970, but until recently it have been too expensive as on a large scale. Originally, RFID tags were used to track large items like cows, railroad cars, and airline luggage that were shipped over long distances. These original tags are called inductively coupled RFID tags, were complex systems of metal coils, antenna, and signals. Inductively coupled RFID tags were powered by magnetic field generated by RFID reader. Electrical current has an electrical component on a magnetic component. It is electromagnetic. Because of this, you can create a magnetic field. You can create a magnetic field with electricity. The name inductively coupled comes from this process. The magnetic field inducts a current in the wire. You can learn more in how electromagnets work. Capacitively coupled tags. These were created next in an attempt to lower the technology's cost. These were meant to be disposable tags that could be applied on less expensive merchandise and made an universal as barcodes. Capacitively coupled tags used conductive carbon ink instead of metal coins to transmit data. The ink was printed on the paper labels and scanned by readers. Motorola's bistatic RFID tags were the fortuners in this technology. They used a silicon chip that was only 3 millimeters wide and stored 96 bits of information. This technology didn't catch on the retailers and Bistatics was shut down in 2001. New innovations in the RFID industry include active, semi-active, and passive RFID tags. These tags can store up to 2 kilobytes of the data and are composed by a microchip antenna and in the case of active and semi-passive tags, a battery. The tag's components are enclosed within plastic, silicon, or sometimes glass. At a basic level, each tag works in same way. Data stored within RFID tags microchip waits to be read. The tag's antenna receives electromagnetic energy from an RFID reader's antenna. Using power from its internal battery or power harvested from the reader's electromagnetic field. The tag sends radio waves back to the reader. The reader picks up the tag's radio waves and interrupts the frequency as meaningful data. Inductively coupled and capacitively coupled RFID tags aren't used as commonly today because they are expensive and bulky. In the next section, we will learn about the active semi-passive. So, what is meant by active, semi-passive, and passive RFID tags? So, what do you mean by active, passive, and semi-passive? So active, semi-passive, and passive RFID tags are making RFID technology more accessible and prominent in our world. So these tags are less expensive to produce, and they can be made small enough to fit on almost any product. So active and semi-passive RFID tags are use internal batteries to power their circuits. An active tag also uses its battery to broadcast radio waves to a reader, whereas a semi-passive tag relies on the reader to supply its power on for broadcast. Because these tags contain more hardware than passive RFID tags, they are more expensive. Active and semi-passive tags are reserved for costly items that are read over greater distances. The broadcast high frequencies from 850 to 950 MHz that can be read 100 feet or more away. It is necessary to read the tags from even rather away. Additional batteries can boost a tag's range to over 300 feet, which is also 100 meters. Like a wireless devices, RFID tags broadcast over a portion of electromagnetic spectrum. The exact frequency is variable and can be chosen to avoid interface with other electronics or among RFID tags and readers. In the form of tag interface or reader interface, RFID systems can use a cellular system called time division multiple access to make sure the wireless communication is handled properly. Passive RFID tags rely entirely on the reader as their power source. These tags are read up to 20 feet away, and they have power. So, and they have a lower production cost, meaning that they can be applied on less expensive merchandise. These tags can be manufactured to be disposable along with the disposable consumer goods on which they are placed, whereas a railway car or would have an active RFID tag, a bottle of shampoo would have a passive tag. Another factor that influences the cost of RFID tags is data storage. These are three storage types: read write, read only, and write once, read many. A read a read write tags data can be added to or overwritten. Read only tags cannot be added to or overwritten. They contain only the data that is stored in them when they were made. Write once, read many. Tags are have additional data like another serial number added once, but they cannot be written. Most passive RFID tags cost between 7 to 20 cents US. Active and semi-passive tags are more expensive, and RFID manufacturers typically don't quote prices for these tags without first determining their range, storage type, and quantity. The RFID industry's goal is to get the cost of a passive RFID tag down to 5 cents. Each one's more merchandise adopted. In the next section, we see about the technologies of dark tags. So here you can see when the RFID industry is able to lower the prices of tags, it will be lead to the ubiquitous network of smart packages that track every phase of the supply chain. Store shelves will be full of smart labeled products that can be tracked from purchase to trash can. The shelves themselves will communicate wirelessly with the network. The tags will be just one component of this large product tracking network. The other two pieces of this network will be the readers that communicate with the tags and the internet, which will provide communication lines from the network. Let's look at the real world scenario for this system. What would be the real world scenarios of RFID tags can anyone say in a simple manner? Next, is there anyone who can explain a simple example scenario in your day-to-day life about an RFID tag where to be used for any kind? Guys, there are no examples to know why no one is responding to the class. Guys, why no one is responding to the class? Unmute yourself. Guys, one of you respond and say why other guys are not responding. Guys, respond. Why other guys are not responding? So guys, please respond anyone. Guys, if no one is responding, no attendance will be posted. Everyone will be sent as absent for the class. So one of you guys need to be responded.